Всем добрый день. Меня зовут Сергей Соболев. Я специалист отдела
Hello, I'm Sergey Sobolev from the Distributed Systems in Positive Technologies,
формальной
and
верификации
today I will speak about formal verification and
и как вообще сделать свой код безопаснее.
Certora Prover and how to make the code safer.
Формальная
What's this
верификация —
formal verification all about? Formal verification is the mathematical proof of the proper
чтобы
terms of our application just to test whether it really works like we would like to do. Formal verification is made up of specification, which is description of the rules of how it should be done, and the implementation. We have the program, we have the source code, and the formal proof that we ultimately have from checking the equality of specification.
Что?
What's wrong?
Формальное доказательство, которое получается
Formal proof that we get from checking the equality of specification and realization. So it's all based on mathematics. It's based upon two things, SAT and SMT. SAT was the Boolean formula, Boolean satisfactory problem, whether we can find a set of variables which will be matching this Boolean expression, whereas SMT goes a little bit further and generalized on that problem, and it added some theory to the formulas.
Значит, у нас есть SMT и
So we have SMT and the SMT.
находят решение данных уравнений.
They find the solutions to the equations, and there are plenty of them, and they may be all different, and some of them resolve it in a faster way, some of them are working slowly. So, for example, the Z3 and Elderix, when, for example, Z3 was launched, I launched it personally, and it would solve the equation for 1 hour, and Elderica did it for 15 minutes. And the SMT solver works like this. It just transfers the initial code to the formula and then finds the solution. For example, we find the formula that we can see on the slide on X42, and then we put some condition, and we see whether Fi equals and F from C. So here is the solution. There are plenty of them. And what would be the performance of SMT solver? It would run the check, and it would change this equation to negation. So instead of equals, it becomes less.
У нас найдутся решения к этому уравнению, то есть
if we find solution to this equation, if we find it, if F from A becomes less than F from C, then it would be the proof that the previous solution was wrong. So if we transfer everything to the code, there will be the function with the requirers, prerequisites, and assert, which will be checked by SMT solver.
Certora Prover
Certora Prover made a tool of their own for searching for vulnerabilities. It's made up of the specification language, and it has some utilities in Python, in Java.
Есть еще инструмент мутационного тестирования, по которому
we have some motivation testing.
И есть еще проверка эквивалентности двух view. Но
the couple of view functions,
пока еще в бета-тестировании.
And it works like that in beta tests.
Solidity они еще поддерживают.
And apart from Solidity,
плюс через eBPF
they support EasyQuiper, and through eBPF they support Solana.
Как вообще все происходит у них на инструменте?
How it's all happening in their tool. The source code compiles into EVM bytecode.
инструмент уже работает не
So the tool
с
itself
изначальными исходниками, а
does not
именно
work
уже с
with the initial source files, but with the bytecode, and we
который должен
rely
быть у нас
upon the
в новом.
compiler
Точно так же
that
происходит с Viper.
should be
Все
installed.
это
The
декомпилируется
same
во внутреннюю форму,
happens to
которая
the
бывает
Viper.
несколько
It
раз статическим
decompiles
анализатором,
to the
и
formula,
далее
which
генерируется
is
у нас
processed by the static analyzer,
условия проверки,
and we
которые будут
just
проверяться
generate the
уже
conditions on the
внутренней
verification.
формулой,
It will be
статической
verified
формулой и проверены вместе со
and put
спецификацией
into
на
logical formula. It will be
И
checked at
дальше
the
вот отсюда
SMT
получится второй
solver.
пример, который мы сможем
So we will
проверить,
have the
посмотреть, что
counter
не так,
example, which we
исправить.
check and
Либо
verify
наоборот, у нас
and
будет
change
доказательство того,
something.
что свойство сохранилось, и
So
можно и дальше не беспокоиться.
the other things that you should not be worried
Сама
about.
Certora Prover, она работает
The Certora Prover
тройке Horn.
utilizes
У нас есть
the
состояние до, вызывается какая-то функция,
previous state, the horn triplet,
все очень просто.
and the state after. Everything is simple. We need to describe what we had before, what we need to call
Состояние изменилось.
for just to change the state and see whether the state was changed properly and whether it was changed according to our rules. They position themselves as the tool that simplifies the test for the people. Automation plus the generation of the counter examples. And they position themselves as a maximum safe
плюс
tool
максимальной автоматизацией. Единственное,
with maximum automation.
тот же самый слизер запустите.
So if you launch the static analysis,
какой-то отчет, здесь вам надо будет поковыряться немного в коде для того, чтобы
here you will have to pick the code a little bit, and you don't really know how you will write this specification because it's a separate form of art.
если вы неправильно напишете,
So, for example, if you write this specification in the wrong way,
помимо всего прочего,
you will
есть
be
еще и другие
checking the rules in the wrong way. There are other tools as well. So on the left-hand side,
Daphne, K-Framework,
Isabel Hall, Daphne, Lean,
примерно занимаются тем же самым.
they approximately do the same.
Единственное, что они являются просто как ассистентами для создания доказательств.
They may be assistants to create the proof, and they are much more loaded, and there is less automation.
И, соответственно, безопасность инсового
So the security of the tool
заключается в том, что
is about using the mathematical approach, and when we speak about fuzzer
статические анализаторы,
and the static analyzer,
автоматизация и там, но
it's the automation.
исходного кода становится не таким, что и большим.
It's not so big,
У них
basically.
есть свой язык, который очень похож на Solidity.
They have their own language, which looks like Solidity.
Проблема состоит в том, что он
But the only problem is that it does not support mapping and the type of the function and
также у него есть еще
the
дополнительные
massives.
типы,
And
которые позволяют
it's got additional types which allow us to write more specifications like the environment, which contains global variables in Solidity, method, where you can get the modifiers like view or pure and selectors. So out of this method, you can get that as well, and then I'll show you how you do it. Call the targ, which is the symbol variable which replaces all of the arguments of any time, and storage, which is the snapshot.
Когда он был вызван. По возможностям у нас Certora дает написание правил.
Gives us the rules writing principles. That's what I explained. We explained this state before with the requirers. We call a certain function, and then we see whether the state is correct. The embedded rules are the same, but they are reduced to the minimum, and they check the read-only entrances.
Поиск некоторых паттернов,
and they search for specific patterns that already exist there.
делают на то, возможно ли вообще решить
And they check and
данное
verify
правило.
whether this
Сложный
rule
код, потому что
applies or the
некоторые логики
initial source
происходят
code
настолько обширно,
was
что очень
too
сложно
hard
будет решателям дальше все это
to
доказывать.
track, and the solvers will have problems
Такие правила, которые навешиваются.
doing it further on. We also have some parametric rules that are put on all of the contract functions that we check and verify. Invariants that check and verify
Сохраняется ли
whether
состояние
the state is kept intact while contract is non-performing. It's a little bit different from the rule, but basically it does the same. One more thing, it just checks the state of the contract after it was deployed by the constructor, and the rules don't do that. There is a function where you can put your code, so it does not take much space. Macros and defines in C++.
Переменные призраки, которые
variables, ghost variables that reflect the state of the contract so that you can write the specification properly. And hook E, the hooks that work with lowers and stores and other hook codes that the Certora language supports. As far as syntax is concerned, it's approximately the same as in Solidity. When we start writing specification, we just need to identify the block of methods, which is made up of those methods that we will have to verify. It's not a mandatory thing, but for convenience, it's necessary. There's also the ENV3 directive that specializes in showing that this function is not dependent on the environment, and it does not need all these variables that NSG, TX, and block. And you can see the invariant expression. It's a small one, just a couple of strings, unlike the rule.
Также в правилах
on the right, but also you can call up invariants and check them.
Обозначение как раз-таки переменной.
And there is a definition of a variable. Apart from identifying ghosts as variables that reflect the state of the contract, you may add your own ones and check their states when the hooks had been applied, and you go back to the rule and see whether it was changed correctly or not. On the right, you have the rule, which is a parametric rule. So here we have the prerequisite precondition when we fix the total supply. The actual rule identifies whether the total supply changes,
какой функции он может определяться, и
which function it can be determined by. It can be changed by a mint or burn. We can either mint or burn the tokens, as it were, if any other function changes total supply. It will violate the properties. Certora Prover will show it all, will reflect it all. So we fix the state before, go through the functions with the F method. The F method fixes the environment, and that's how it works. Then we fix the total supply after. If it increases, then by condition we see the changes, and it was changed by the mint function. If it reduced, then it's just because of burn. This is what the report looks like. It's the overall plan. If you drill down, you will see the rule which defines that only the holder can change the resolution so that somebody would spend their tokens. It was the parametric rule. All the contract functions were reflected there, so the rule is followed.
Уменьшается вот это вот аваланс пользователя.
So the avalanche of the user changes. Then we check
трассировку транзакций, call trace.
The tracing.
Мы видим, что типа
then we check the call trace.
Win 256 и какое нынешнее состояние вот.
And we see the current state.
Переменные
of the local variable and which state they are. So you can see it here. So initially the balance before equals 0, it has grown. However, we called the function of reducing the resolution. However, the rule looks like this. We have the definition of what was the condition before, and we call up this parametric rule and see the state after. And then if we see that if it increases, and it was done by MSG sender, by the one which was defined by the holder, so if it increased, then the second assert, it's either approve or increase allowance, which enhances the resolution. So everything hides in detail. So in the source code, we see that the functions that change the allowance for tokens expenditure calls approve, which increases that with the minus. It's all wrapped into unchecked
underflow, когда у нас 0 минус,
which influences underflow, overfull, or underfull when the number is not negative but goes back to the maximum number or minimal number.
Тут бы хотелось бы как-нибудь
So here I would like to interact with the floor. So here is the task for us, a logical task, which will help you identify how the specification works and how we'll define the post conditions with Certora Prover. We have 4 friends, Mikhail, Evgeny, Bogdan, and Dennis, and they all mine their own cryptocurrency.
Вообще текст должен быть виден вам всем.
So I believe you can read this text. Monero, Ethereum, Bitcoin, Dogecoin.
Условие странное.
So there is a strange condition. Once Evgeny says that it's horrible, and neither of them has their first letter of the name matching with the first letter of the cryptocurrency that they mine.
И это как раз-таки тоже ME, Ethereum,
that's ME, Ethereum, Bitcoin, Dogecoin. So I'm not against that. The friend says, who mines Monero? It's easy for you to say, says Bogdan. It would be great if the first letter which my crypto starts with was a vowel, but it's not. So here is the challenge for you. Do you have any... Okay, they will give you the microphone.
На первый вопрос можно ответить быстренько. Нет, они атаки на сеть не позволяют.
They do not consider the attacks. They just consider this as a source code.
Интерактив с залом. Да, просто повтори. Практически не слышно было.
Хорошо.
So could you please repeat your question? It's about Bogdan. We know that they don't mine Bitcoin because the first letter does not meet Ethereum.
И не Monero, потому что он отвечает.
Because he is answering the friend who speaks not about Monero.
Dogecoin.
So Bogdan mines Dogecoin, I guess.
Так.
Еще кто-нибудь?
Anyone else?
Нам надо определить, кто какую криптовалюту майнит.
We need to define who mines which cryptocurrency, judging from this task.
Денис?
Манера майнит не... Можно?
Monero,
Не Евгений, не
it's not Evgeny.
Михаил, значит, Манера майнит Денис.
Monero is mined by Dennis.
Потому что, ну, они, видимо... Нет, ну, у нас Евгений как бы первую реплику...
Evgeny was the first one.
Кто майнит Манера.
Да, тут
So,
что
who mines Monero?
дальше ответил ему
Евгений.
И, соответственно, Евгений и Богдан уже точно не майнят Монеро. Вот, ну, тут условно 3 человека общаются. Что? Да.
Манера. Но дальше биткоин Евгений майнит.
So,
И что там еще осталось?
Bitcoin is mined by Evgeny, and what's left?
Ну да.
What's left in there?
В Certora Prover, ну вот у нас опять же есть
Certora Prover.
решение. Михаил
So we have a solution.
биткоин, Богдан Dogecoin, а Денис Monero.
I think Denis Monero, Bogdan,
То есть,
Dogecoin.
типа, вполне себе
You can express this
с помощью языка, там,
with a simple language, and Certora Prover can push in the empty contract, which will not verify anything, but you will describe it in the specification, the logical task. If someone knows about Sherio, I respect you.
Мы формально уже определили, что
We define
определение того, что типа Monero это единица.
that there is a definition. Monero is
Нам надо еще ограничить
number one, and we need to limit the variables of the names.
Что ну, типа, являться от единицы до 4.
So it depends of what they are. Otherwise, Certora Prover will squeeze in 100 or less, but not just these values. And that's what you need to pay attention to when you write this specification, because some of the values need to be approximated. Then we have the first condition, that neither of the letters or numbers meet the first letters of the numbers of the cryptocurrency. Then Evgeny
общается с чуваком,
meets
который майнит Monero, и Богдан тоже не майнит.
with the one who mines Monero.
Майнящий Monero. Вот. И также Евгений у нас не добывает эфир, потому что
Eugene here is not mine. Bogdan is not mining Ethereum because his first letter is not the vowel. So here we just need to define that we don't need to repeat the variables. And here is the sanity true.
Если в стандартном исполнении,
if in the standard equation, Certora Prover finds the counterexample, here we can find everything that matches our conditions, whether it matches it properly or not. Then we can put up the second rule, which will define the uniqueness by putting assert in there and checking whether there will be any other solution, and both the rules actually apply. Just like a few slides ago, we just check this in the interface, we check all of our rules and local variables.
Также еще у них есть очень
Also, they have a very good tool for testing.
Он занимается именно
Gambit
мутантов. То есть вообще
that generates the mutants, because they generate the mistakes in the source code. If the test passes, the mutant stays alive. If not, the mutant is killed and destroyed, and our target there is to kill all the mutants. The Gambit
мутантов, которые вы уже дальше
just generates the mutants, and then you will have to write a script so that it automatically will put it in, and you can use it together with the specification so that
покрыли исходный код спецификации.
so that we cover the source code of the specification,
К ним также на сервер и проверяется.
and it's uploaded to the server and it's checked. If we compare Gambit with other tools of the mutant tests, it's a weak tool. It's generating a minimum number of mutants from those of them who exist there, which does not support solidity, only arithmetic and logical.
Отчетик, он выглядит
So here is the report. We have two rules, the outer circle, R1 in the bottom, and the mutants which we covered and called by following this rule. So you click on the mutant and you define the rule which killed the mutant. We also have the coverage, share how many mutants were killed,
правила их отловили, и, может быть,
what were the rules, and there may be two rules identified, applied for the same mutant.
Мы после того, как использовали, мы можем уже посмотреть,
After we've used it,
какие были изменения при
we can check what were the changes brought into the source code so that we could define
это нормальная ошибка или нет, потому
whether it's a normal error or not, because the mutants may change the source code, but in certain cases, but it may not affect the testing result, because the business logic will not be anyhow distorted.
Хотелось бы услышать какие-нибудь вопросы.
This is it. I'm done. I would like to listen to the questions from the floor and read some questions here, if you like. So can anyone and give me the answer how it can be blocked, unblocked, I mean.
Виктор.
Okay, Victor is asking about
инварианты фазинг-тестированиях, которые
what about the fuzzing tests?
Перебираются. Ну, то есть, типа, если взять фазинг и формальную верификацию, чем...
If we take the fuzzing and the formal verification, what's the difference? Fuzzing just selects the values which will be sent to contract, and formal verification goes deeper. It brings the code to the formulas, which will be proved.
От этого становится больше. У нас, грубо говоря, если фазинг там переберет 5000 вариантов...
If fuzzing selects 5000 options, 5000 variants,
формальная верификация, она докажет то, что ко всем параметрам...
Formal verification will prove that all of the parameters will maintain it or not. But what about contracts? Will there be asynchronous requests sent to contracts? For example, one request is still running and then the second one starts. Do you mean used in parallel? Used in parallel. Yes, a few specifications can be launched for checking and verifying that. I'm not talking about that. No, I'm more talking about checking whether there is verification. That there are some asynchronous requests, whether it will work well or not. I mean, the transactions. Well, in principle, we can identify this transaction that after such and such transaction, we will define the state of the contract, and we can state it and then express the second transaction and ask them generate a random transaction, which will be a symbol one, and then check the state after. So thank you for your answer.
Либо погромче скажите, либо там микрофон дадут.
So there is another question. Could you please use the microphone for questions?
Да, здравствуйте, спасибо за доклад.
Yes. Hello. Thank you very much. I'm not very close to this topic, but as a programmer, I would like to ask you whether it's going to be very expensive to do this specification and reveal the bugs in it. How expensive will it be? And
Спецификацию по факту, ну, вы сами пишете.
well, the specification.
Исходный код, ну, на основе того, что у вас, ну, вот есть код. И вы
You have this code and you write the rule.
найти в ней ошибку будет достаточно сложно. Только надо сидеть,
And
смотреть, что правильно ли вы выразили.
you just need to check and see whether you've expressed it
то, что изначально хотели.
properly.
Да.
You will not just do it in a simple way, but testing it, just the mutants may change it, whether the source code was changed, whether the specification will pass. If there is something more complicated, you can be mistaken and pay the price. So very often there are some false results that are very hard to track. Well, in principle,
решатели могут в
the
некоторых
SMT solvers can sometimes provide us with the positive results.
В принципе, типа, ну, за тайм-аут вышло, и все. Ну,
If it goes beyond the timeout, you can do whatever you like. You just simplify the rules or the code.
но все-таки, типа, ложно-отрицательные также еще бывают все-таки, и все.
And I believe this is it.
Но для этого используется, там была...
But for this, I was actually showing you the
что используется
architecture, the scheme with the architecture that we use 3L, Derica, Viper, and CVC.
я так понимаю, минимизировать вот это вот расхождение.
To minimize the discrepancy that the Z3 may not cope with that. Thank you very much for your presentation. Thank you very much for your answers.
Да нет, ну то есть...
I didn't hear the question, but that's the answer. It's a very complex task. Sometimes you just need to sit and wait for it to be checked. But basically, it may work. Thanks very much for your presentation. Whether you can interact with the data that get the contract elsewhere, how the analyzer will act. There is a definition like the chaos,
Оно прописано. Только единственный момент, что
the interaction.
если код контракта неизвестен,
So, for example, if the code of the contract is unknown,
из неизвестного контракта, то они могут быть, естественно, произвольными и
they may be random,
принимают как просто какой-то набор
and the
данных.
instruments perceive them as the set of data. You can limit them.
Напишем спецификацию, мы можем сделать разные, нанести типа разные ограничения.
So we can put different limitations to how it's done.
Вызываем эту функцию в
So when we call this function in the contact, maybe it should be addressing the data which is already there, and thus we reduce
потому что верификация контракта
possibilities of verification of the contract by saying that we would put certain amount of data
спецификацию
by turning this specification into unit testing.
от этого, но
So the coverage reduces, yet we may check and verify this quality.
вопрос, да.
I hope this answers the question of yours.
Certora — это
Certora
сервис, они
is the semi-free service.
ну, типа, вы можете временную почту
So
поставить, и так
they would send it by mail, and then you generate the keys,
ключи, которые вы
and the verification goes through the keys that
можете
go through account.
запросов в
So
месяц,
you can get a certain amount, a number of requests per month,
бесплатно
and initially they would give you the key
и всё.
just for 4 months, and you can do it for free.
Сравнивать, ну, сравнивал ли я с другими.
Here is the question. whether I compared that with other methods of analysis,
насчет того, что фазинг и
then I spoke about
тестирование, оно
fuzzing and testing, which gives less coverage by code.
про фазинг тоже отвечал.
And I spoke about that, and I spoke about fuzzing.
Гарантий дополнительных.
And it does not guarantee anything. So there's a formal proof. And if we compare it with the stat analysis of fuzzing and mutation tests,
также еще есть другие инструменты, которые
there are other tools
следующий коллега мой расскажет.
that the next colleague will explain us here about the use of the concert.
Есть еще прикольный инструмент.
There is a great tool, by the way.
Презентации дальше. Есть от самих разработчиков.
It will be followed in the presentation. There is a thing from the developers of Solidity,
Недавно была статья, там, где
MT-Checker, and they had an article. They compared MT-Checker with Certora. What's good about Certora is that the same Solidity as MT-Checker and the symbols and all of these utilities are based upon your particular machine, which is good. Nobody will ever see the code, but you'll just need to get the computing power from somewhere. Whereas Certora sends everything to the cloud, and it's checked and verified in the cloud. So even if you have a laptop which is not so powerful, you can still check and verify your code by specification.
Проверяются ли программы на Solana?
Another question, whether the Solana-based software is checked on Certora. Yes, it's checked, but in a limited way. Solana is another block chain, like Ethereum. It's got its own language for writing the contracts. Rust compiles eBPF. Maybe they heard about that.
И
the bytecode
eBPF проверяется уже у них, как спецификация написана.
And they check how this specification is written.
Я никогда не разрабатывал на Расте, но можно найти примеры. Даже их туториал.
You can find some examples, and even their tutorial is not working on the computer. They provide so that you can
дай Боже, когда-нибудь она будет работать. Если что-то похожее на гамбит на Solana, тут надо уже смотреть и искать. Скорее всего, вам подойдет какой-нибудь мутационный мутационное тестирование. Оно вообще уходит далеко по времени.
Which goes beyond in time.
Даже. И, в принципе, Rust...
It goes back to the 90s. And if Rust is used in Solana, the generator of mutants in Rust does exist. I don't really know which one exactly. Maybe a universal mutator, which allows to generate a lot of languages like Solidity and Viper. Rust may be a very popular language because it was added there.
Да, Виктор спрашивает, если уже заготовлены
Victor is asking,
SMT спецификация
says,
во-первых, сама Certora
MT specification from MC20. Certora audited Open Zeppelin, and they came up with the main ERC20 rules for Open Zeppelin. You can take them from there, and you can run this certification on a token, see whether the main functions are performed correctly.
Да, кстати, один еще плюс.
And yet another advantage that we have there, this specification can be reused. For example, if you write a project of a similar kind, you can embed it and use this using, prompt, and import, all the other things like that.
Какие знания и опыт нужны для написания спецификаций? Наверное, все-таки можно сказать, что нужно понимать
What can we use for the specifications?
тот язык, синтаксис, который,
The language and the syntax that we use there.
под что вы проверяете. Плюс, опыт в программировании и
Get this experience with programming and general understanding of what you actually do.
также надо, вот как мы сейчас смотрели на примере логической задачки,
If this logical task is shown,
условия, которые мы должны проверить, мы должны при получении исходного кода понять,
with this source code, we just need to understand what are the properties of the source code.
и дальше уже описывать их формально на
And then we describe them formally in the language of mathematics by putting them into the CVL language.